The future of space may not be designed by humans, but by algorithms. Relativity Space, a company you may not know, is rewriting the space race. Instead of relying only on traditional manufacturing, they're using giant 3D printers, artificial intelligence, and generative algorithms to create rockets in ways that were impossible just a decade ago. In this video, we'll explore how AI is changing space exploration forever, how rockets can design themselves, how AI predicts failures before they happen, and how the biggest names in aerospace are now competing in a digital arms race. Stick with me, because at the end, there's a twist that might make you rethink what building a rocket really means. AI doesn't just speed things up, it actually invents. Relativity Space uses generative AI to design rocket parts that are lighter, stronger, and more efficient than anything engineers could sketch by hand. Imagine asking an AI to test millions of possible shapes and materials, and then picking the one design that balances strength, weight, and fuel efficiency. That's how you get rockets that push the boundaries of physics. But design is only step one. Relativity Space also pioneered massive 3D printing for rockets. Their Stargate printers, powered by AI, constantly monitor themselves. Machine learning algorithms check every layer of metal as it's printed. They detect defects instantly, correct errors in real time, and make sure the rocket structure is flawless. AI also predicts when machines will fail, before they break. Every sensor in Relativity's factory feeds into predictive models that tell engineers exactly when to service equipment. The result? Less downtime, fewer delays, and smoother launches. AI doesn't stop at the factory. It simulates missions before rockets even leave the ground. By running thousands of scenarios, AI can optimize fuel, payload weight, and orbital paths. That means safer launches, fewer risks, and higher mission success rates. Even the supply chain runs on AI, predicting shortages, managing inventory, rerouting orders, all streamlined by algorithms. And internally, generative AI tools like ChatGPT are used to query technical databases, write documentation, and reduce errors. In short, AI isn't just part of Relativity Space. It is Relativity Space. Would you trust an AI to launch you into space? Think about it. Your life in the hands of an algorithm. AI autonomy is vital for deep space missions. When communication takes 20 minutes one way to Mars, you can't wait for human commands. Spacecraft need to make decisions themselves. AI enables autonomous navigation, problem solving, and survival in the harshest environments. AI also manages satellites, optimizing their orbits, coordinating fleets, and even dodging dangerous space junk. With tens of thousands of objects orbiting Earth, AI is the traffic controller of space. Instead of sending raw data back to Earth, spacecraft can now process it locally using AI, what we call edge AI. This saves time, bandwidth, and resources. And generative AI tools help design entire missions, from satellite constellations to interplanetary journeys. SpaceX uses AI to perfect rocket landings, calculating trajectories so precisely that boosters land on ships in the ocean. AI also powers Starlink, managing thousands of satellites in orbit. Blue Origin relies on AI for predictive maintenance and engine design. Their rockets, New Shepard and New Glenn, benefit from AI-optimized mission planning. Rocket Lab integrates AI into autonomous spacecraft operations. Astra uses it to speed up prototyping. In this new race, every company is betting on algorithms. Even traditional players like Boeing, Lockheed Martin, and NASA use AI for satellite design and autonomous rovers. The industry is shifting, and fast. AI reduces costs by minimizing waste, accelerates innovation by designing faster, and improves mission reliability with simulations. As of mid-2023, Relativity Space had already sold over $2 billion in launch agreements, proof that this model works. But AI isn't perfect. Poor data leads to flawed designs. Hackers could disrupt systems, and as AI takes control, ethical questions grow. Who is responsible if an AI-designed rocket fails? The engineer, the company, or the AI itself? Regulators are scrambling to keep up. International organizations are writing standards. Governments are defining accountability. Even export controls restrict AI technologies in aerospace. The rules of the game are still being written. Relativity Space is pushing for AI-driven sustainability, reducing material waste and energy. Their next rocket, Terran R, will be fully reusable and deeply AI optimized. And with digital twin technology, every rocket exists first as a living, learning virtual copy. Here's the twist. Relativity Space isn't just printing parts or running simulations. They're creating digital twins, rockets that exist virtually, learn from mistakes, and improve themselves before they're ever built. In other words, the rockets are designing themselves. Humanity may be stepping into a future where machines are the architects of our journey to the stars. Would you ride an AI-designed rocket?